Welcome to geometry class. In this video we're going to look at chapter 17 section 1, circumference and area of a circle. Here's our warm-up. Draw and label the following parts. Well, a radius, we're just going to go from the center to the edge, and I'll put an R for radius. Diameter goes across the circle and through the center, so red is our diameter. Circumference, I'm just going to, let's write circumference, that is the distance around the circle. And then for chord, I'm just going to pick 2 points on the circle and connect them. As long as we don't go, well, if we go through the center, the diameter is a chord, but here's another chord that just goes from these 2 blue points. Okay, and then it says explain the meaning of the circumference. Well, it's the perimeter of the circle. We could write perimeter, P-E-R-I-M-E-T, perimeter of the circle, or the distance around the circle. Distance around the circle. And then what is an explanation for the meaning of area of a circle? The amount of space it takes up. Amount of space circle takes up. So there's our warm-ups based on yesterday's lesson. Let's dive into today's. Some fill in the blank for your notes. The circumference of a circle is the distance around the circle. The ratio of the circumference of any circle to its diameter is a constant defined as pi, Pi, which is the irrational number 3.14159 ... And that brings us to our definition for the circumference of a circle. The circumference, capital C, of a circle is C equals pi times diameter, or C equals 2 pi r. 2 radiuses make up the diameter if they're straight across from each other. Where D is the diameter of the circle, R is the radius. All right, in example 1 here, we're going to find a couple of circumferences. So in letter A, they give us the radius. The radius is 7 millimeters. So we're going to use circumference equals 2 times pi times r. So we could multiply, well, we could plug in the r is 7 millimeters, and 2 times 7 is 14. So our exact answer would be 14 pi millimeters. And if we use the 3.14, the pi button on our calculator, we'll get a rounded off decimal, so approximately 43.98 millimeters. So again, in part A, they gave us the radius and we plugged it in the formula. In part B, we have the full diameter. So let's use circumference equals pi times diameter, our other circumference formula. So we're just going to plug in 58 for D, so our circumference is 58 pi. That would be our exact answer. And if we use the pi button on our calculator, we'll get our decimal of about 182.21 yards. Again, our units in the first one were millimeters. Second one, our units were yards. Now here it says find the diameter of a circle with this circumference. So if they're asking for the diameter and we have the circumference, let's use the same. Circumference equals pi times d. So now the circumference is 65.97. That is equal to pi times the diameter. How do we get the letter d alone? We're going to divide both sides by pi. So here the pi cancels, and we're going to have our diameter is approximately, if we do 65.97 divided by pi, we should get 20.9989. That's pretty good. Let's round that up to 21. Diameter is about 21 meters. Got to have our units on there. Okay, let's see what's next. Example 3. We are building a new traffic circle. It would have an outer circumference of 1/4 mile. What should the radius of this traffic circle be, rounded to the nearest foot? And then they give us a little fact that there are 5,280 feet per 1 mile. So here in step 1, determine the circumference in feet. Well, the circumference is 1/4 of a mile, and a mile is 5,280 feet. So we're going to divide 5,280 by 4. And that is going to give us 1,320 feet. Circumference is 1,320 feet. Now, step 2, use the circumference formula. Well, circumference is equal to 2 times pi times the radius. And we just found our circumference here. Circumference is 1,320 feet, and that's equal to 2 times pi times the radius. Again, if we go back to the original problem, we're asked to find the radius of this. So we want to get this r value alone. And to do this on the calculator pretty quickly, first let's divide by 2. Divide by 2. So you'll punch in your calculator 1,320, divide that by 2, hit equals, and then divide that by pi. And if all goes well, the radius is about 210.08. And they did ask us to round this to the nearest foot. So that's just going to be about 210 feet for the radius. Okay, now formula for the area of a circle. The area of a circle is, now this is a little typo, that C there should be an A. Area equals pi times radius squared, where of course r is the radius of the circle. So in example 4 in part A, find the area of the circle with the given info. Well, our area formula is area equals pi times radius squared. And in letter A, they give us this radius right here. So it's going to be pi times 2.8 squared. Remember your order of operations. PEMDAS, we want to square the 2.8 before we multiply it by pi. So the 2.8 squared is 7.84, and then that'll be times pi feet squared. Squared footage because we're finding area. And if we multiply the 7.84 by pi, we could also have the rounded value of 24.63 square feet. Now when we come over to part B, they didn't give us a picture, but they did give us the diameter. Area equals pi r squared. Well, if the diameter is 18, the radius is going to be half of that. So our area is pi times 9 squared. 9 squared is 81. So the exact area is 81 pi. In this case, it's inches squared. And if we multiply the 81 by pi, we're going to get approximately 254.47 inches squared. All right. Example 5, we're building a splash pad as concrete areas with circular non-slip surfaces. The diameter D for each circle is given. The non-slip surface costs $11 per square foot. What is an estimate for the cost of the non-slip surface? So I'm going to color code this. Here is circle number 1. Circle number 1 is right here. Diameter is 20 feet. So its area is going to be pi times 10 squared. 10 is half our diameter. And then we're going to do plus circle number 2, I'll do in black ink right here. That is also going to be pi times the radius squared. And here the radius would be half of 18, or 9. And then plus, we've got our third circle. I'll use blue ink. Circle number 3 is going to be pi times half of 14 is 7. 7 squared. So let's square these numbers. Our 10 squared is 100. So circle 1 is 100 pi. And circle number 2, we would square the 9 and get an 81 times pi. Plus 7 squared is 49 times pi. So we can add up all these pi's, and then we got 230 of them. 230 pi. Now this is our area in square feet. Let's multiply the 230 by pi, and we should get approximately 722.57 feet squared. Now that's our square footage, and each square foot costs $11. So we're going to take that answer and multiply by 11. So our estimated cost is about $7,948.23. And there we go, example 4. In example 6, find the circumference of the circle with this given area. So they gave us the area is 121 pi inches squared. So if I write the blank formula here, area equals pi r squared, we can plug in the area right here. That's 121 pi equals pi times radius squared. So we want to solve and find the radius, because what we're going to do is then use the circumference formula. Circumference is 2 times pi times r. So we're using this formula to solve for r. That r is going to go in here and give us our circumference. So let's go back over here. To get r squared alone, we're going to divide by pi. So these pi's just cancel. And we have 121 is equal to r squared. Well, 11 squared is 121. So if I square root both sides here, I'm going to have r is equal to 11 inches. Again, we're going to take that 11 inches and plug it in right here for this radius. So now our circumference is 2 times pi times 11, which is 22 pi. That would be our exact answer. And if we multiply 22 by pi, we get approximately 69.12 inches. Again, that's our circumference. All right, I think we've got one more example. And here we've got somebody named Disha states that the circumference and area of the larger circle are both double the circumference and area of the smaller. Is she correct? So let's see what she did here. We got a big circle with radius 10. And here's a smaller circle with radius 5. So she's saying if we double the radius, the circumference doubles and the area doubles. So let's see what happens here. I'm going to do the big circle. Oop. Let me move this up, give myself a little more room. So here is the big circle. Area is going to equal pi times the radius 10 squared. So that's area is 100 pi. Circumference is equal to 2 pi times the radius, and the radius is 10. So the circumference of this one is 20 pi. Now I'm going to switch to blue ink. Let's compare that to the smaller circle. The smaller circle has a radius of 5, so its area is pi times the radius 5 squared, and that will be 25 pi. The circumference is 2 times pi, and the radius is 5. So the circumference there is 10 pi. So the radius here was 5, and when we doubled it, we had the radius equal to 10 on the bigger. And it does look like the circumference is double also. Here the circumference is 10 pi. On the bigger circle, it is double that, 20 pi. So Disha was right about that, but here's where she goes wrong. Area of the small circle is this. If we double that, we would expect a 50 pi, but actually we got 100 over here. So she was incorrect about the area doubling, but she was correct about the circumference doubling. And what it does say, explain why or why not. I think the smoking gun here, circumference is 2 pi r, area is pi r squared. We have this squared, and a squared number grows a lot faster. So that's why it throws the area off. It's not a linear relationship. All right, practice time. If you want to pause the video and try the practice problems, you can start it back up and see if you got it right. So let's see what we have here in the first one. Area and circumference of these. A circle with radius 4. So r is 4. Area equals pi times radius squared. That would be 16 pi. And I'm going to write it in here. 16 pi, or approximately 50.27. And that would be in inches squared. Our circumference is just 2 times pi times r. So that'll be 2 times 4, or 8 pi, is our circumference, which is about 25.13, and that would be in inches. In part B, our diameter is 22, so that means the radius is going to be half of that. So our area is going to be pi times radius squared. 11 squared is 121. So our area here is 121 pi, or approximately 380.13 yards squared. When it comes to circumference, we could just do pi times diameter. Diameter is 22, so our circumference is 22 pi, which is approximately 69.12 yards. Okay, number 2. Find the diameter of a circle with this given circumference. Well, circumference equals pi times diameter. We know the circumference is 21.99 is equal to pi times diameter. And we're going to divide both sides by pi. And that's going to make our diameter equal to 6.9996. I have no problem if we round that to a nice 7 feet for our diameter. All right, number 3, find the circumference, and we have a given area. So once in this, we did an example like this, we're going to need both formulas. Area equals pi r squared. Circumference equals, what are we trying to find? Circumference equals 2 pi r. So over here, we have the area. The area is 49 pi centimeters squared, and that's equal to pi r squared. So we're going to divide both sides by pi. So these pi's cancel. 49 equals r squared. If we take the square root of 49 will be 7. That 7 is going to go right here. Circumference equals 2 times pi times 7. That is 14 pi. And 14 times pi is approximately 43.98. Our units here are centimeters. All right, number 4. A pair of sunglasses have circular lenses. So let's draw. So there's our glasses. Lenses each have a diameter of 1.8 inches. So this red diameter is 1.8. Determine the length of wire that frames each lens. So they're not asking for the total. Round to the nearest tenth. So circumference equals pi times diameter, and our diameter was given as 1.8. So 1.8 times pi is approximately 5.7 inches of wire. And now in part B, a polarized film is embedded in each lens to filter sunlight. How many square inches of polarized film is needed for both lenses? So we need to find the area of one of the lenses and then double it. And our area formula is pi r squared. Well, up here they did give us the diameter was 1.8 inches. Half of that would be 0.9 inches. So our area is pi times 0.9 squared. So 0.9 squared is 0.81. 0.81 times pi is about 2.54 inches squared. Now remember, we got 2 lenses, so we're going to need 2 of those 2.54. And if we double that, we get 5.089. And that would be inches squared of our polarized film. All right, number 5. A circular horse pen provide rehab exercise for a horse recovering from an injury. To the nearest foot, what is the total distance the horse travels in a lap? So here's our picture right here. The radius of this pen is 20 feet. So the distance around would be the circumference. Circumference, let's use the 2 times pi times r, because we know the r is 20. So that's going to be 2 times pi times 20. And that is also as 40 pi. And 40 pi as a decimal, it is 125.66 feet. But they want it to the nearest foot. So we're going to round that off 126 feet every time the horse does a lap around the pen. So now it says, how many seconds does it take the horse to complete 5 laps? Well, if we're going to do 5 laps, and each lap is 126 feet, that means the horse is going to travel a total of 630 feet. And let's read here in the box, the horse trots at 15 feet per second, 20 feet from the center. So if they're going around that outer edge, he's going 15 feet every second. So we're going to take this 630, we're going to divide it by 15 seconds, and that turns out to be a nice 42, and then our units would be feet per second. Feet, or no, we're dividing this, so it's how many seconds. So yeah, it's going to be 42 seconds. All right, let's see part C. Suppose the horse trots around the pen 18 feet from the center at the same speed. How much less time would it take to complete 5 laps? So we're going to need a new diameter for our new circumference based on our new radius. So we're going to do 2 times pi times r. Up here it was a 20, but now it's going to be an 18. So that's going to be 36 pi, which is approximately 113.1 feet per lap. So now we're going to take that 113, we'll just round it down to 113, and we're going to multiply it by 5 laps. So 113 by 5, the horse has traveled 565 feet total, and if they do 15 feet per second, because it says they are going to go around at the same speed, we're going to divide that distance by 15 feet. And that turns out to be approximately 37.67 seconds. So the question was how much less time? So in part B up here, we had 42 seconds, and we're going to subtract the 37.67, and that leaves us about 4.33. Approximately 4.33 seconds quicker, because they moved in a little bit on that radius. Okay, and our last problem here is going to make you a better purchaser of pizza. We've got 2 pizzas, and what is it? $10.50 for a medium, $12.50 for a large. The medium has a diameter of 12. The large has a diameter of 14. Which pizza is the better buy? So let's see. Here I'm going to do medium on the left. The medium pizza has a diameter of 12-inch diameter. So let's find its area. That means a 12-inch diameter. Its radius is 6 inches. So the area of our medium pizza is going to be pi times radius 6 squared. That is 36 pi, or approximately 113.10 square inches. Now, if we take the price of that pizza, the medium pizza was $10.50, and we're going to divide that by the 113.1 inches squared, And if we do that, we get approximately 0.09 dollars. So that's 9 cents or $0.09 per square inch. Per inch squared. Now let's go over and do that to the large pizza. The large pizza has a diameter of 14, so that means the large has a radius of 7. Let's find the area of the large pizza. So that'll be pi times 7 squared. That's 49 pi. And 49 times pi is about 153.94 inches squared. And then we're going to take the price of that large. The large pizza was $12.50. We're going to divide that by the 153.94, and we get about 0.08. So that'd be 8 cents or $0.08 per square inch, per inch squared. So if we break it down to how much you're paying for a square inch, you're getting a better deal with the large pizza. Okay, that is the last practice problem. That is the end of Chapter 17, Section 1. I hope the video helped.